Yeah, so we've had 1 degree of warming so far roughly across the planet, and there is different rates of warming in different areas. And we're trying to limit with the Paris Agreement warming globally to 2 degrees. So it's a very relevant, interesting question about why does 1 or 2 degrees actually make so much difference for species. And that's because small changes in the physical environment have really large biological impacts. And we already all know that, because I'm sure everyone in this room has had an argument at some point in time about the thermostat in the office or at home, or the car, somewhere like that. People arguing over, I want 22 degrees, no, I want 23. People, we're quite sensitive to small changes in temperature. And we're animals that are endotherms, so we can actually regulate our own body temperature to a certain degree, whereas most marine animals can't. So they're even more sensitive to changes of 1 or 2 degrees in the environment. And I've got an example here just to highlight why that 1 or 2 degrees makes such a big difference. This here's heart rate, and that's temperature. I've got heart rate here, but this could actually be almost anything about an animal. It could be how quick it grows, it could be how much oxygen it uses, it could be how fast it can swim. Almost any biological process will follow a particular pattern with temperature. And that pattern is, as it's cool, that process might be relatively slow. It'll speed up as it gets to an optimum temperature that particular species will prefer. And then after it hits the maximum, it'll generally have a pretty rapid drop-off with how efficient that particular process is. So you could imagine if this was growth rate, it might be, the lobster example here grows, half a kilo in a year if it's 20 degrees, but it might grow a kilo in a year if it's 25 degrees. So it's a really quite common phenomena that almost every biological process with every animal will have a reasonably well-defined range where it's maximal for that process. Using this example, heart rate, for example, at 24 degrees is its absolute maximum capacity for that animal. We push it 1 degree more and it's almost halved, that heart rate. So this is why that 1 degree actually makes a heap of difference, in particular for where animals live. So plants and animals are pretty well adapted to their local environment. As that environment changes, they can suddenly move into new areas. And we're actually seeing this all over the world. So there is a climate-driven redistribution of life on Earth. There's plants and animals in the northern hemisphere moving north and in the southern hemisphere moving south. The animals and plants are not changing the environment that they like, they're just tracking their preferred temperature as the temperature increases. And it literally is happening everywhere. We're seeing plants and animals go to higher elevations, not quite flying in the sky like that goat is, but you get my point, and deeper in the ocean as well. And these changes in distribution are happening the fastest, where the climate's warming the fastest, and it really is just one aspect of climate change that is affecting ecosystems and humans. But these changes in distribution, this is a map of just some of the key changes in distribution that we've seen, and each one of these has had some kind of big impact, either economic or culturally, or on the ecosystem. That's a handful of examples. There are literally hundreds of thousands of examples of species that are changing their distribution. We are living through the greatest redistribution of life on Earth since the last glacial maximum, which is around 21,000 years ago. And sometimes these changes in distribution we might not notice at all. A little, cryptic barnacle or something moves a couple of kilometres, might not make any difference at all whatsoever. Other species, it can have a really big impact. And most of you will be familiar with this one off your east coast. Kelp beds, throw in a few urchins, and we end up with urchin barrens. And although that's a complicated problem, it does have to do with lobsters and large predators being around in high numbers. The critical part of that issue, though, is the larval stage, which looks absolutely nothing like the urchin, but the larval stage of the urchin has a 12-degree threshold. And that east coast of Tasmania has now hit that 12-degree threshold in winter when the urchin spawns, and so large numbers of the urchin can now survive. And as that 12-degree threshold has actually shifted down our coast, the urchins have shifted down the coast in large numbers. So a complicated problem, does have to do with the fishery and other things as well, but that's an absolutely critical part of it. And basically, as our waters warm, there's a whole lot of other impacts on animals as well. So as the water's warm, animals use more energy to breathe, so their costs go up. They have less energy then to reproduce. Warmer water actually holds less oxygen, so the animal's demands for oxygen goes up, but the availability of the oxygen goes down. And so that can lead to stress on animals, and that can make them more susceptible to disease and things like that. So there's a number of other factors that happen just with that 1 or 2 degree change in temperature.